Hey everyone, um, today I'm going to start learning Java. Basically, I want to learn Java, Spring Boot, and watching and going through lectures is very boring that I almost feel sleepy. So I'm thinking to first read it by GPT and make note to get the theory because honestly, if I tell you I'm that kind of person who like I'm someone who first want to know the theory of it. I don't know why if it's right or wrong, I don't know, but that's how my mind understands. That first I go to theory, I understand it, and after that only when I start coding it, then I feel a bit more comfortable and not so sleepy, not so unpredictable. So today I'm going to just do the phase 0 which I extracted from GPT, that I pasted this command that I want to learn this and prepare index from scratch to advance, and that's how it has prepared. So let's start reading few. So first is what every one starts with. So, what JTK, JRE, and JVM are and how they are related to each other. Now, of course, this is something I have read from very start in college also, that we have a thing as JDK, which is a Java development kit. Inside it, we used to make this box of JRE, and inside that, we used to make this box of JVM. All three things stand for something. Like JVM stands from Java Virtual Machine, JRE is Java Runtime Environment, and JDK is Java Development Kit. Now, so far, what I only know is that JVM is the engine that runs Java program. It reads bytecode, that is dot class files, because that this is what I also learned from some lectures, that first our whatever we have wrote our code got converted to bytecode, which has extension of dot class, and after that the JVM, it converts this bytecode into machine code such that my operating system understands, and that is why this is what we used to call it, write once, um, read anywhere, like something like that, because that this is why, because this bytecode is created, which is dot class, and after that JVM will run it for every operating system. So that is what I got so far, that without JVM a Java program can't execute. Then moving to the next one, which is JRE, Java Runtime Environment. So this has JVM, this has class libraries and some other runtime files. So if you want to run a Java application, installation of this of course is important. And after that we move to this Java development kit. So this obviously has a JRE, then Java compiler, then debugger. So these things exist in it. Now the next one is that how the Java source file becomes dot class bytecode before it becomes a running program. So this though already I mentioned that first we wrote this dot Java file, which is our source code. Then the Java compiler, which is Java C, that is inside JDK. It converts it, it compiles it, and then it will generate a dot class file, which is this bytecode. Now this bytecode is not a machine code, not a source code. It's like a intermediate platform independent code, which our JVM will understand. And then after that, when we run this um, dot class thing, after that our our file get you know will get executed. And there is also a few more thing we read, like class loader that loads the required .class files into our memory. Then bytecode verifier that before executing our JVM verifies the bytecode to ensure that if it is valid, if it's not corrupted, and if it's not performing some illegal operations. Then execution engine, which executes our bytecode by like two ways, interpreter and JIT. We must all have heard of that, just in time compiler. It's more like a hot code or hot reload type, I used to think. So basically, our execution engine, which has two ways, interpreter and JIT compiler. So this interpreter reads bytecode instruction by instruction, and our JIT detects frequent executed code and compiles that into our machine code and stores, so that in future our execution becomes a bit more faster. So that is how we used to run it. Now why it is right, yeah, this is what I was saying. WRA, work, write once, run anywhere. That once we wrote, it got converted to bytecode. Now this bytecode can run on any machine by JVM. Now the next is what the class path is and why Java needs to know where to find your classes. So this is again like not so very tough part. This is something I already know, that a class path is like is more like a list of locations where our Java looks for dot class files and external libraries. It's more like it tells our JVM, our Java compiler, that here is our class which our program needs. Um, I hope you guys get this point. I'm not writing it somewhere because these are a few things which I think everyone must be knowing. It's not something very complicated. If you are confused in this class path, it's just simply understand, like suppose we make a project and we have this main.java thing here, and inside it is some utils which has some calculator.java. Now our main.java uses like something like our calculator C is some new calculator. So when we compile or run our main, so Java must have to find where is our calculator.class. Without knowing this, how would it know that the in main.java the calculator I made is like what? So it will throw class not found exception. So that is why we need class path, because that is like a folder containing .class file, a jar file, multiple folders in jar. How main is the entry point and why? How main method is the entry point, okay, and why is had the exact signature. If I think this though we already have learned, in CPP also, when we used to write, it starts with main because that's what the entry point is. And in Java, that is why we used to specifically tell that this start main with public static void, because so that we don't have to create an instance in order to run it, something like that. So I guess mostly these parts though we have already done. I sort of knew these, so no need to do it so much in this. Next is variable and data types. What a variable is: a named value box in memory. It holds value, of course. Primitive types. This we could learn that this is int, long, double, float, boolean, char, byte, short. Okay. And after that, what each primitive is for, like all this int, long, double, float, what range it holds, and when to use which. Well, this is something we only read. I usually don't remember this. What I only know that 1 byte is something of 8 bits, and 2 to the power 8 to 2 to the power 8 minus, I remember something like this only. So minus 128 to 127. So this is only what I know. I don't go much in the ranges. Who's gonna ask me the range? Then the difference between primitives and object. Well, this is the very important thing, and something in JavaScript I have learned that our primitives are someone that who actually stores value, while our objects stores a reference to an object. It's more like this is someone's house, so this is primitive. But when I say that okay, this particular address, this is a reference to this person, so that is our mostly our objects. And there is also some things na, like something like storing in heap memory or stack. So in primitive case of primitives, it is directly stored and it's stored in stack. Otherwise, in case of objects, the variables stores a reference and the actual object is stored in heap. So this is mostly how it works. So if in future someone asks me that is this string is primitive, this is what it has written, that is it primitive but behaves like one in many ways. So we'll definitely say that our string is not primitive. These are the only ones which are primitive. This is a very like on a shorter level a popular question that these are primitive while these are not. So a string is definitely not a primitive, it's an object which is an instance of like a string class. So yep. Next is our variable declaration and initialization versus assignment versus. I guess by this they some mean like how we initialize variables. So of course in declaration we used to write a data type and a variable name. When we initialize it, so either we could give a value, something is equal to something like int age and then age is 20. Here I have done the initialization. Now assignment is like changing or setting the value of a variable using our normal is equal to operator. So when I say previously I was saying age is 20, now I say age is 25. So this is what it will locate. After that is var keyword, type inference, compiler figures out the type. What the actual I think they are mostly talking about var. Var is I understand it as a variables type from the value assigned to it. Like we used to say var name is jk, our string name is jk, or we say our var age is something, and type inference, it's mention of type inference. I guess time inference though generally means that type and inference. I think it's usually to mean ki by if I say that double price is 99, so it will look at the right hand side and will determine the type of the compiler time. Then cons with final value can't change after assignment. This though I guess we mostly know if we have done any development in any language, because final is what? Final is a keyword, means that the value can't be changed after it has been assigned once. So it's more like assign once and after that it would be read only. Suppose if I say final int and my age is 20, so I will say that this particular thing is how we used final, because at a time it initialized age is 20 and after that you try to change it to age to 25, 30, whatever, it will not change, it will give compile time error. So it can be assigned once only. Then also in this final, I have read this in oops actually, uh, through a channel. I don't remember his name, but he mentioned very good cases, like like if I put final in variable, then what will happen? So the one example that I mentioned, that final int age is 20, so at this point of time this is valid, and when I say age is 25 in the same line, now this is not valid, this will give error. Similarly, if I just keep it blank, that my final int age, I just wrote this and after that I said that age is 20, so this is the good. But again, after once initialized I say age is 34, now it is wrong. Similarly, if we talk of the reference variables, so in that case again what happens? Now this is very interesting. Suppose you make some array list as final, array list of a string that we generally used to do, and when we add list in the same list, suppose I'm adding jmmk, these, so in this case both are true. Because why both are true? Because we are modifying the object, not the reference, so that is why it is allowed. I hope you get it. In any case, if you didn't get it, let's write it. Suppose if I said that my final array list, which is a string list, is new array list. Okay, so I make this. Now when I try to do things like list dot add jm one time, and after that again I want to say that list dot add gm, so here both are good. Because why? Because we are modifying the object, not the reference. By this what I mean, that this is good. But at the same time, when I say that my list is some new array list, I already um, chosen a reference, and that reference I am changing, so that will give me error. This is what I was saying. So a final reference always means that a reference point can't point to a different object, but the object itself can be modified unless it is immutable. Then we have final methods also, in which we can't override a final method. Then final classes also, which can't be extended. So like these are like 4 5 things that we got to know about the final. After that is our operators and expressions. We'll just go through it. Arithmetic is plus minus, we all know. Integer is this. Now see, 5 divided by 2 gives 2, not 2.5. Why this happens and how to fix it? Well, this is interesting. Integer division. When I divide 5 by 2 gives 2, not 2.5 in our Java. Then why this happens and how to fix it? Uh, 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 this is interesting. Well, not that much interesting, of course, because I think both are integers, so it will give answer as integer. Had I put any one as a float, then the whole answer would have come float, or we could just typecast it. So I don't think there is so much here. Then comparison, then logical. Then assignment, then ternary operator, then operator precedence, which evaluates first. These are the all okay. I'm okay with these. Then after that is our control flow, which has if else, which for while loop, do while loop, for each, break, continue. After that, some methods, like what a method is. So it's a named block of reusable component, return type. The method gives back something. Then parameters, then method signature, then calling a method. Then method overloading, that is same name, different parameter types are count. Name is same, just parameters are different. Return statement, which is more like exit method. Static means something that belongs to the class and called without creating an object. And why main is static? Because Javens calls it without creating any object first. Then memory model. This we already understand earlier, that how our primitives get stored in stack, uh, in a heap memory where objects lives and managed by garbage collector. By these we mean that if I say int x is equal to 5, so 5 lives in the stack. When we say our dog is this, so dog object lives on heap, and this d is a reference which is memory address to it. So heap, which one has gone into heap? This dog. But what is d doing here? D holds a reference memory address. What happens when you do this? Do copy the reference. You copy the reference. Both variables point to the same object. Wait, what they mean? First they created a dog d is equal to new dog. Okay. Now dog object lives on a heap, and d holds a reference memory address to it. Now they are asking what happens when you do dog d2 is equal to d. The previous d and this one d are matching. That is, we copy the reference, both variables pointing to the same object. Sorry, I got a little gone with it. Okay. So basically, both are copying to the same object. That is though I understand. So dog D is already something and dog D2 is D. So by first we created a dog, and dog is in heap. The variable D stores reference object to this memory, that D from our above example. Let's make it here. Let's say here, so I'll just make a point that our D stores a reference to that object. So where is D? D is in stack memory, this one. But whatever it stores, it's in a heap. So it's like whatever our dog object is, that is in heap memory. Now when we do D2 is equal to D, so no new dog is created. Instead, Java will copies the reference object in D into D2. Now both the variables point to the same object. So now previously our D was this. Now our D2 will also become dog object, which is same. Now in heap the same thing is there, but the pointer to it is coming from the different locations. Where, so when we in case will modify this, so both will refer to the same object and changes made through the reference are visible through the other. So this is what is it saying, changing these two fields, what D does too, because they point to the same object. Garbage collection, Java automatically removes object from heap without nothing reference them anymore. Null is a reference that points to nothing. Okay, this is all okay. What is a string? So a string is an object, but Java gives it a special treatment. Java string is immutable, of course. Once created, we can't change it. Then is more flexible. String pool is what Java keeps a pool of string literals to save memory, and this is true because they point to the same pool object. Why is this is strong? Two different heap objects. Wait, this is the way long. This should not be here. Even the whole thing should not be here. Always use dot equals to compare, not this. Okay, string builder is mutable, used when building strings in a loop. These length, char, substring, contains, replace, split, trim, starts with, ends with, to uppercase to lowercase, these things. Then array, which is fixed size, then the declaration part, the initialization part when we access it, when our index is out of bounds exception, then iterating with loop, and for each loop 2D arrays. That is all okay. After that is our exceptional handle try catch block. Finally, this is very important. Finally block always runs whether exception occurred or not, used for cleanup. Throw manually throws an exception, and throws declares a method might throw a checked exception. Checked exceptions कैसे, जैसे आयो हो गया, अनचेक्ड में null pointer हो गया, illegal argument exception हो गया. Why Spring Boot use unchecked exceptions anywhere? Forces you to handle what you are chasing to less in this boilerplate. Then basic input output. Well, where was I? I felt a little sleepy in the meantime. Checked exceptions are IO, then null, and then illegal argument exceptions. Then why it uses unchecked exceptions everywhere? Forces you to handle only what you choose, less boilerplate. Creating custom exceptions. Extend runtime exception for unchecked and exception for checked. ठीक है. Input output printf. This is new line. This is without line. This is formatted output. This is scanner for reading input. Now we did most of the basic thing, stack, heap, object and all. So basically our fundamentals and phase 0 is completed. Now we'll move studying to phase 1.